Hey writers, today we're going to talk about the standard algorithm for finding equivalent fractions. So standard algorithm sounds like a very long, complicated word, but really what it means is it's the mathematical shorthand, if you will. It's the fastest way and the most efficient way that we can solve the problem using numbers and symbols like multiply or divide or add or subtract. And we have standard algorithms for most of the things we do in math in 5th grade. We have long division and we have multi-digit multiplication, and we'll see all of that later on. But we already talked about the picture strategy for finding equivalent fractions, so I wanted to show you the standard algorithm, the more efficient way to do it if you're ready for this step. So I have a fraction here, 2/3, pretty basic fraction. We can picture what 2/3 of a pizza or 2/3 of a sandwich would look like. And we need to find an equivalent fraction, a fraction that represents 2/3 but goes by a different name. All right, so here's what you can do. We can change the 2 and the 3 to come up with a new fraction. But here's the key. We have to change both the 2 and the 3, and we have to change them in the same way. So what I mean by that, for example, I could say 2 times 5. If I choose to do 2 times 5, then I just need to make sure I do times 5 down here also, okay? Then I'm just going to see what that equals. So 2 times 5 is 10. 3 times 5 is 15. So 10/15 is an equivalent fraction to 2/3. And I could do this with literally any number in the world. So let's take it down a notch. Let's say 2 times 2 and 3 times 2, right? Because I have to change them in the same way. All right, so 2 times 2 is 4. 3 times 2 is 6. 4/6 is an equivalent fraction to 2/3. So key points to remember, I'm going to put them up in the corner while we work here. The only way you can change the numbers is by multiplying or dividing them. Okay, so here I chose to multiply. And you have to do the top and the bottom in the same way. Okay, so I'm going to use a little shorthand here. So we can only multiply or divide, and we have to do the top and the bottom in the same way. All right, let's check out another fraction. Let's try 4/10. Okay, now I could do the multiplication again. I could say 4 times 3 and 10 times 3, or 4 times 100 and 10 times 100. Those would be fine. But I also notice that both of these are even numbers, which means 2 can go into both of them. So I could actually reduce this fraction or make it simpler, make the numbers smaller, if I divide the top and the bottom by 2. Okay, so 4 divided by 2 equals 2. 10 divided by 2 is 5. So 2/5 is an equivalent fraction to 4/10. Okay, let's look at one more example. We'll make it slightly more complicated. Let's do 51/60. Now, you thought we'd never talk about prime and composite ever again, but here it is to rear its ugly head back at us, okay? I want to divide these fractions. These numbers are really big, so I want to make these numbers smaller to work with. So I want to divide the numerator and denominator. Well, what numbers do I know that go into both 51 and 60? Okay, 51 is one of those really fun numbers where your brain goes, oh, that's prime. Nothing goes into 51, but it does, okay? So the number 3 goes into 51, and I know that because 3 times 20, okay, that's 60, right? 3 times 20 is 60. If I go down, if I take away 3, if I do 3 19 times, okay, I just count back from 60. 59, 58, 57, okay? So that equals 57. Okay, if I take away 3 another time, I go 57, 56, 55, 54. Okay. All right, so this is if you do it 18 times. And then, oops, sorry, 54 is if you do it 18 times. There we go. Then I'm going to take away 3 one more time. So 54, 53, 52, 51. Okay, so if I do 17 times 3, I actually get 51. Okay, that's one of those super tricky little prime and composite numbers. They really like to try to sneak away. All right, all that to say that 3 does go into 51, whether we want to believe it or not, right? All right, so 51 divided by 3, we just saw was 17. 60 divided by 3 is 20. All right, so 17/20ths is an equivalent fraction to 51/60ths. Now here's the ever important question. How do I know when I can't divide anymore, when my only option is to subtract, right? How do I know that I can't divide 17 and 20 by anything? Well, think about what you know about the number 17, right? The only numbers that go into 17 are 1 and 17. The numbers that go into 20, then you got a few more options. You have 1, 2, 4, 5, 10, and 20. Maybe I'll squeeze the 20 in there. All right, so they don't have any numbers in common. The 1 is shared between the two lists, but remember, if you divide something by 1, you just get the same number. So if I divided the top and the bottom by 1, I'd get 17/20ths again. My goal is to try to change the number, right? So I see that they don't share any other numbers, so I know that this fraction cannot be divided by anything else. It is as reduced as it will go. So I could go in the opposite direction and multiply it by something, right? And any one of these examples that we've done, you could prove with a picture. You could draw a fraction strip, but the wonderful thing about the standard algorithm is you don't have to, as long as you understand what's happening. All right, this is the 5th grade strategy for finding equivalent fractions. So if you feel like you're ready for it, go ahead and give it a shot on your next fraction problem. Thanks for watching.